In earlier class,
This
seen
call is now being recorded.
in earlier class we had seen about periodic signal, and if signal is periodic, what will be a fundamental period? How to find that we had seen, and for today's class we are going to see second different types of signal, which is called energy signal, energy versus power, energy signal versus power signal. So when we call signal is energy and when we call signal is power. So this is what we are going to understand here. So the statement for this, we call signal energy. A statement for energy signal. Signal will be called as energy signal when energy becomes finite. Energy becomes finite and power is power becomes zero. So that's energy signal. Please remember this. Energy of that signal will be finite and power of that signal will be zero. And what about power signal? So for power signal, my statement, when it is called power signal, answer for this, when energy becomes infinite and power becomes infinite. So we call that signal is power signal. Remember, energy infinite. I'm very sorry. Here power is okay. I'm very sorry. Please let me rectify this, students. Energy becomes infinite and power becomes finite. So for this case, when we call this energy signal, when energy becomes finite and power zero, and for power signal, when power becomes finite, this will be a little rectification. So when power becomes finite and energy becomes infinite, then we call that signal is power signal. That's it. This is what statement. And on the basis of this statement, now we have our definition, mathematical equation, I would say, for energy and power signal. So again, here we are going to consider two cases, first for discrete time and second for continuous time. So let me have one table. In first column of this, consider continuous time signal. Continuous time signal. And in column of this table, you consider discrete time signal. Great. So for discrete time signal, we have to equation for energy and power. So when we have a continuous time signal, what will be a mathematical expression for energy? So here statement, expression will be energy integration minus infinity to plus infinity mod xt whole square dt. And what about this power? Power, energy upon time. So here, if I consider this equation, energy upon time minus infinity to plus infinity mod xt whole square dt. This is what we have energy definition. And what time is? Time is minus infinity to plus infinity. This is my total time, minus infinity to plus infinity. So this is what we have total time, students. So if you write time values from according to this equation, that will be infinity, no. So something upon infinity, it gives you always zero. So we don't write this way. We don't directly put this value here. So what we do here in mathematics, we do a little modification in this equation. See what way we are going to modify this. So rather we write this minus infinity to plus infinity. We do this way. We apply the concept of limit here, and then we have to incorporate this infinite case. See here. So this will be, I'm considering total time is t. Okay, fine. So I'm considering this way, minus t by 2, minus t by 2 to plus t by 2. Okay. So what total time is now? Total time is minus t by 2 to plus t by 2. Now total time is capital T. So this is perfect. But here you see in this expression, this lower limit is minus infinity. So I wanted this to be infinity, means approaching to infinity. What should I do? So in mathematics, simply you apply this limit t tends to infinity, students. So when t tends to infinity means this is equation like this only. So that depends on function. What xt function is, first we have to solve it, and then later we apply t tends to infinity, and then we have to see what kind of this power, whether it is finite or infinite, right? So this is what we have, a general equation for continuous time signal for energy, and this is for power. All right, in the same way, if we consider for discrete time signal, so in continuous time, we have integration. So in discrete, in place of integration, you have to use summation. This is what you have a difference. So here I will be considering summation. And here, time will be replaced with a small n. So n will go from minus infinity to plus infinity mod xn whole square. Am I audible, students? Am I, my voice is okay or still cluttering? Students, am I
No, sir,
audible?
it is okay.
Yes, sir,
Yes, sir,
it's
you're
okay.
audible.
Perfect, perfect. And same way, if you consider this power signal, so power signal is what energy upon time. So same mathematics we apply here also. This is summation I will be considering here now, minus n to plus n. Okay, minus n to plus n mod xn whole square. But this n should be infinity. So here you apply limit n tends to infinity. Okay. So now what is total time? Minus n to plus n. You see here total length of this time. Suppose this is minus n, and this side you have plus n. So as I told you, this belongs to discrete data. So of course here data will be discrete, means for at every instant of time you will get your amplitude of this signal. So I would like to know what is the length of this time? What is the length of this? So you see this way you will count. Suppose this is at this point we have one sample like this amplitude. At this we have this. At this we have this sample, and so on and so forth. It goes like this. Suppose we have this kind of signal in this range. Now I would like to know what is the length of this time. Okay, you consider one example. You take n equal to 5. So if you take n equal to 5, so this will be minus 5. Just you consider n equal to 5. So minus 4, -3, -2, -1, 0, 1, 2, 3, 4, 5. Right. So what is the length of this time? So this side you have 5 seconds. This side you have 5 seconds. See, 1, 2, 3, 4, 5. So 5 plus 5, 10. And at 0, we have one sample. So 10 plus 1, that gives you 11. So when you have 5, you are getting 11. So how you are getting 11? Means 5 when time is negative, 5 for time positive, and 1 at 0. So 5 plus 5 plus 1. So in general, we can write this is 2n plus 1. Length of this time is 2n plus 1. You simply keep n equal to 5 here. So 2 into 5 plus 1, that gives you 11. So this is your total time. So when you have this limit n equal to minus n to plus n, so total length of this time will be 2n plus 1. So here my total time is 2n plus 1. Any doubt in this to understand how it comes 2n plus 1? Students, any problem in this?
No, sir.
No, okay. Sir. So this is what you have by equation for energy and power. So that depends what question comes. If it is related to continuous time signal, we have to use these two equation. So to say energy, to say a signal is energy, so it should be finite. This should be finite, and this power value should be 0. So if this is finite, this is 0. So we can say that signal is energy signal. If energy is infinite, if this is infinite and this is finite, signal is same true for discrete time signal you apply here. But you have different to use summation. Here you have to use how we conclude whether the signal is energy or power. So and in one power as well, both case for discrete as well as for continuous. So question is determine the given signals, the given signals are energy or power signal. First part, we are considering continuous time. Say xt equal to equal to what example you consider? You take xt equal to e to the power j 6 pi t. Okay. And okay, one more question you take. B, you consider xt equal to something like you may consider ut, unit step, basic elementary signal I consider. So what ut is? Ut equal to 1 when time passed. So this is for continuous time. Next, you may consider for discrete also. So for discrete, you may consider x of n equal to, you may consider this way, 1 by 2 to the power n un. Okay, and d you may consider x of n, something like x of n equal to 1. No problem. All right, so the question may ask, okay, please let me know what kind of this signal is, energy or power. So I will solve one from each. Rest you have to solve, students. Just understand the concept. How do we solve this? So first, let me solve this part first, continuous, and then I will go for discrete. So in continuous, I'm going to solve A, B. I'm leaving for you to complete. So what you have a definition for energy? So energy says this is minus infinity to plus infinity mod xt whole square dt. So what mod of this complex function? This is your complex e to the power j 6 pi t. Okay. So let me put it this value here, minus infinity to plus infinity mod e to the power j 6 pi t whole square dt. And mod of this complex quantity is 1 cos 6 pi t plus j sine 6 pi t. If you take mod, that gives you under root cos square 6 pi t plus sine square 6 pi t, and that value is 1. So simply I may write here minus infinity to plus infinity. This mod gives you 1 dt, and if you integrate, that gives you t. Apply this limit minus infinity to plus infinity. So this is infinity minus minus infinity. That gives you twice infinity, that is infinite. So here we are getting energy of this signal. What we have, complex signal. This is infinite, students. Then only we can conclude. So power is what? So power is 1 by t limit minus t by 2 to plus t by 2 mod xt whole square dt. And here this limit t tends to infinity. So now we are going to solve. So again, you have to take a mod of this. Mod x means this value you have to put 6 e to the power j 6 pi t here, and you take a mod. So here also mod gives you 1. So this power will give you limit t tends to infinity 1 upon t integration minus t by 2 to plus t by 2 mod of this one. Simply we have dt, and now if you integrate, that gives you limit t tends to infinity 1 by t. What you have, integration t, and you put upper and lower limit, that gives you t by 2 minus minus t by 2. Then what? Limit t tends to infinity 1 by t by 2 minus minus plus, that gives you t. So t cancel out. So now you apply limit t tends to infinity, but this is independent of t. So this gives you 1. So what is my observation? Observation is here energy is infinite and power is finite. Energy is infinite and power is finite. So what kind of this signal is? Could you please let me know, students, what this signal would be? Which case it satisfies, power or energy? Vanshika?
So energy.
In energy, it says energy of that signal is finite and power 0. And power 0. We are not
Yes,
getting power 0, students.
yes, so power is
Only,
finite. Uh,
yes.
yes, sir.
So it will be a power signal, right?
Yes, sir.
So so in power signal, what you have, energy is infinite and power is finite. So this is power signal. So sometimes it may be a case where it does not satisfy any cases, right? So in that case, you say neither energy nor power. So if this case satisfies, we say signal is energy. If this case satisfies, we say signal is power. If both cases are not satisfied, then we can say that signal is neither energy nor power. So this will be your answer for that case. Okay. Now coming to in the same way you can solve for part B. I'm leaving for you to complete what you have to apply. Simply you have to put UT here. UT value is what? Let me solve the students. So perhaps you may have confusion. So let me solve both to avoid any kind of confusion. Wait a minute. Let me complete all four. Okay. So B part, if you consider this B, xt equal to ut. You understand this function? Ut is what? Ut is one, that is unit step function. This I have already covered in my previous to previous class. This is one when time positive, means t is greater than 0, and this is 0 when t lesser than 0. So once we understand this function, now we apply what we have mathematical equation for energy. It says minus infinity to plus infinity mod xt whole square dt, mod xt whole square dt. And you see, when time negative means minus infinity to 0, this xt will be 0. So if you integrate 0, that gives you 0. So there is meaningless to, if you consider minus infinity to 0, that effort will be useless. So why should we waste our time by considering this time minus infinity to 0? So rather we consider uh, limit 0 to infinity where this function is non-zero. So under this limit, this xt will be 1 because t greater than 0 means 0 to infinity dt. And if you integrate this, that gives you infinite. So again, here energy is infinite. So what about power? So power is limit t tends to infinity 1 upon t. So what you have a limit minus t by 2 to plus t by 2. Minus t by 2 to 0, we have amplitude 0. So we don't consider this limit minus t by 2 to 0. Rather we take what? This one I have to take. Limit t tends to infinity 1 by t. Limit is, now I will be taking 0 to t by 2, rather this limit. Why? Because in this range, I'm very sorry students, this, yes, correct, minus t by 2 to plus t by, so upper limit is what? We have t by 2, perfect. So this goes from 0 to t by 2, there is no problem, perfect. So only thing is that we have to ignore a limit, what we have, minus t by 2 to 0, because in this range, this function is 0. So if you integrate this, you will be getting 0 finally. So we are considering here limit 0 to t by 2, where this function is non-zero. So in this range, this will be 1 whole square is 1. So 1 dt. So you integrate it, that gives you limit t tends to infinity 1 by t. Integration of this t by 2 minus 0, that is t by 2. So this t cancel out. And now this is free from capital T. If you apply limit t tends to infinity over this constant, that gives you constant value only 1 by 2. And this 1 by 2 is finite, students. So this is finite, this is infinite. So what this is again what we call this? Am I
Energy.
audible?
Yes, sir. So energy it will be because energy becomes finite.
But energy is infinite, no. Energy we are getting infinite, no. And
Yes,
power
sir.
we are getting finite.
Yes, sir. Power it is. Power becomes finite. Yes, sir.
Yes, yes.
Yes, sir.
So that will be your power signal, right?
So why you have considered from 0 to infinity? Can you explain
Uh,
this one more time, sir?
uh, okay, okay. See here, if you consider this function xt equal to ut, if you draw the graph, it says when this is your time t, this is your xt. So when t greater than 0, you are getting this 1. This is 1. When t lesser than 0, you are getting 0. So if you consider this, so what we have minus infinity to 0, what we have magnitude 0, no. So if you integrate 0, finally you have result 0. So why should I waste our time over this when magnitude is 0, or we can say amplitude is 0? So if you are integrating this, you are getting 0. You can do it. There is no problem. You can do this way also. Minus infinity to this way you can break it. Minus infinity to 0 mod xt whole square dt plus 0 to infinity mod xt whole square dt. So when you have this range minus infinity to 0, what amplitude is 0? So this gives you integration minus infinity to plus infinity 0 whole square dt. So what is the integration of this? That will be 0, no? So why should I waste here? Why should I waste our time here? That's why I simply ignored this, because this gives you always 0. 0 plus this gives you this value only. That's why I directly go for this function. Rather, I go for minus infinity to plus infinity. Understand?
Yes, sir.
Okay. Okay, so now coming to our discrete part. This is second part, we can say. Here you consider xn equal to 1 by 2 c, xn equal to 1 by 2 to the power n un. So what kind of this signal is energy or power? Okay. So because this is your discrete, so you consider this summation now in place of this integration, and goes from minus infinity to plus infinity. So what we have mod xn whole square. Okay, so now see here. This function, now you have to understand this function basically first before you find energy. So what un is, un is 1 when time n is greater than equal to 0. This I have already covered in first class itself. So un will be 1 when time positive. So this will be what I can say. This is 0 when n negative, means when time negative, means minus infinity to minus 1. This function will give you 0, no? If un 0, so 1 by 2 to the power n into 0, that gives you 0. So simply I can say this function will be non-zero, means 1 by 2 to the power n when time, discrete time n, greater than n equal to 0. That is the meaning. So when n greater than equal to 0, un will give you 1. So 1 by 2 to the power n into 1, that gives you 1 by 2 to the power n. That's why I have written this. And when time negative, un will be 0. So 0 into non-zero means 1 by 2 to the power n, that gives you 0. This is for time negative. So what I may write now, if you put this function in this expression, so what limit will be? So limit will be, now I will be considering not from minus infinity. I will be starting from 0 to infinity. Why 0 to infinity? Because minus infinity to minus 1, this xn means this function is 0. This is 0. So summation of 0 will be 0 always. That's why we don't consider this range. Don't consider this range because this gives you 0 value. So where we are getting non-zero when time is greater than n equal to 0. So that's why I started from 0 and it will go up to infinity. And in this, what you have function in this range, we have 1 by 2 to the power n. So you put it here. So this is 1 by 2 to the power n, xn, and this is whole square. So now you have to solve it. This is n equal to 0 to infinity. This gives you 1 by 4 to the power n. Why 1 by 4? 1 by 2 whole square is what? 1 by 4. So 1 by 4 to the power n. Now you open it. So put n equal to 0. So 1 by 4 to the power 0. N equal to 1. 1 by 4 to the power 1. N equal to 2. 1 by 4 to the power 2. And so forth. This way it goes up to infinity. And you see what kind of this summation, sum of the infinite series. So you might have studied in 10 plus 2 arithmetic progression, geometric progression, and harmonic progression, right? So here you see this is a common ratio that we are getting 1 by, sorry, this is what, yes, this is 1 by 4 to the power 0 is 1. This is 1 by 4. This is 1 by 16. Next will be 1 by 4 to the power 3. So that you see what number comes. So if you take this ratio, 1 by 4 upon first term, that is 1 by 4. If you take this ratio, you will be getting 1 by 4 upon 1, that is 1 by 4. 1 by 4 whole square upon 1 by 4, again 1 by 4. So what you observe, that common ratio is now becomes equal. So if common ratio becomes equal, that series will be in GP series, students, geometric progression. So this is in GP series. So in GP series, you know what expression is. If we have sum of the infinite GP series, result would be like this. If you remember, that gives you 1. This is your first term. 1 by 4 to the power 0 is 1. So 1 upon 1 minus r. What r is? Common ratio is 1 by 4. So 1 minus 1 by r. So this is what, if you solve it, that gives you 4 upon 3. So again, we are getting for this function, what we call energy, that is 4 by 3, and this is your finite value. Understand this. So for energy, we are getting 4 by 3, that is your finite value. Clear, Vanshika,
Yes,
Anuradha?
yes, it's clear.
Now coming to this power signal. So power signal is what? That says 1 upon 2n plus 1, 1 upon 2n plus 1, summation n equal to minus n2 plus n. Okay, no problem. Mod xn whole square. And limit n tends to infinity. So again, you put it this value. So what range will be? Range will be 0 to n. Why 0 to n? Because for time negative, this un will be 0. So we will be considering here this limit n tends to infinity, 1 upon 2n plus 1, summation n equal to 0 to n. And in this range, this will have this function only 1 by 2 to the power n. And if you do a square, that gives you simply this 1 by 4 to the power n. And now you have to expand and you have to solve. And after solving, you have to check it out whether this is finite or infinite. Now see how we are going to solve this. So next step, just simply algebraic calculation, nothing else. Limit n tends to infinity, 1 by 2n plus 1. N equal to 0, this is 1. N equal to 1, this is 1 by 4. N equal to 2, 1 by 4 whole square. And so forth. Up to how long? Not up to infinity, up to n. So this will go up to n. This is sum of the finite GP series. It was sum of the infinite GP series, and this is sum of the finite GP series. So you might have, again, I will recall your basic mathematics, which you have studied in 10 plus 2. If you have some of the finite GP series, you might have remembered this term a into 1 minus r to the power. If you started from 0 to capital N, it goes from 0 to n means 1 minus r to the power n plus 1 upon 1 minus r, where a is initial term, r is common ratio, n is your number of terms, right? So simply I have to put this and we have to see what result comes. So 1 upon 2n plus 1. First term here, a is 1. So this is a is 1, 1 minus r. Common ratio is 1 by 4. So it goes from 0 to n. So this n is what? 0 to n means total n plus 1. Total length is n plus 1 upon 1 minus 1 by 4. Now see here, if you apply this limit, limit n tends to infinity. Now thing is that now we have to apply this limit. This is 1 by 4 students. 1 by 4 means decimal value 0.25. 1 by 4 is 0.25. And 1 by 4 is 0.25 to the power n plus 1, right? To the power n plus 1. If this n goes to infinity, so decimal value, power infinity, this value will be very, very smaller, no? Very, very smaller. Why very, very smaller? Because this is decimal value. For decimal value, if you take power, that value will be very, very smaller. So if this value is very, very smaller, so I may ignore this value as compared with this one. So simply we have this one because when n goes to infinity, decimal to the power infinity, that is very, very smaller value that we are going to ignore uh, when we have 1. So in compare with 1, we are going to ignore this value. Then what we found here, that simply you have 1 into 1, that is 1 upon 1 minus 1 by 4. So that this term, if you solve, that gives you finite value, that gives you 4 by 3. So 4 by 3 into 1 by 2 n plus 1. So if n infinity, something upon infinity, that gives you 0. So this ratio 1 upon 2 n plus 1, that gives you 0, students. So 0 into 4 by 3, that gives you 0. So here, this result is basically 0. When you find power of this signal, that gives you 0. And when you find energy of this signal, that gives you finite value. So what is your conclusion? Energy here is finite and power here is 0. So if energy becomes finite and power 0, that signal is called what? Students?
Power signal.
No, energy signal.
Yes, energy signal.
So this is your energy signal, students. This is my conclusion. This is your energy signal. So I'm leaving last problem for you students to complete. So you please do this homework from your side.
Okay,
You
sir.
answer me. You answer me in next class. What is this signal? This signal belongs to which category, either energy or power. So once you answer, then I'll go for next topic. And next topic under this classification of signal will be uh, even signal versus odd signal, or we call symmetric versus asymmetric signal. So that I will see in next class. So that's all for today, students. Any confusion, please let me know.
No, sir.
Okay.
No, sir.
Okay. That's all for today. Thank you.
Thank you, sir.
Thank you, sir.